Now that we know about angles, we're going to use that information to talk about triangles. So the first thing we need you to know about triangles is that for any triangle, no matter how big it is or what shape it is, whether it's a right triangle or a little skinny triangle or an equilateral triangle, the measures of three angles in the triangle all add up to 180 no matter what. So we're not going to spend a lot of time in the video talking about drawing triangles, so take a look at pages 477 to 480 in your book about drawing the triangles. This is a little summary of how to draw a triangle, so if you want to pause the video and read that, you can. It's just taken from your book, so go ahead and take a look at that if you want. So what we're really interested in here next is what we call similar triangles. Similar triangles have the same shape and the same angle measurements. However, the two triangles may be of different sizes. So it's a little weird to think about the same shape with triangles, because of course they have the same shape if they're triangles. But we mean a little more than the same shape, just the fact that they're triangles. If you imagine that this triangle is not really the same shape as this triangle here. Whereas this triangle, as well as I can draw at least, may be the same shape as this triangle here, just a different size. So that's what we mean about similar triangles have the same shape, but different sizes. These two don't have the same shape here and here, so they're not similar. And we don't judge that just by glancing at it and seeing that it has a different shape. That's what the same angle measurements tell us about it, that when we measure the angles, if all the angles are the same in the two triangles, then we know that they're similar triangles. We don't have to just glance at it and try to figure that out. Okay, so if we want to try to figure out whether these triangles are similar, we're going to talk about corresponding angles. So we need to be able to measure the corresponding angles and see if they're the same in order to decide if the triangles are similar or not. And what we mean by corresponding angles are in that same shape idea. They're the ones that look like the same kind of triangle angle. So you can imagine in this little drawing I made, crude as it is, this angle looks like it corresponds to that one because they look like about the same angle. So that's what we mean by corresponding angles. So in this drawing here, angle A, which is 70 degrees, corresponds to angle P, which is 70 degrees. And then B corresponds with Q. And then C corresponds with R. So there's each angle, when you have two triangles that are similar triangles, each angle has a corresponding angle in the other triangle. So they also have corresponding sides, and the corresponding sides sit between two corresponding angles. So in this one, side AB, which is this side here, that side we say corresponds to side PQ on this one, which is this side right here. So since angle A corresponded with angle P and angle B corresponded with angle Q on the last slide, that means that side AB corresponds with side PQ. So then similarly, BC corresponds to QR, AC corresponds to PR. So angle PQR and triangle PQR and triangle XYW are similar triangles. So this is a problem you're being given, and this is a statement. So this isn't asking whether they're similar triangles. This one is telling you that they are, and it's asking you to list the corresponding angles and their corresponding sides. I picked one here intentionally that's a little bit confusing because this is the one that people tend to have trouble with. So it says name each triangle in another way that correctly relates the corresponding sides and angles. So what we're really after here is we want to link up the correct corresponding angles so that we can link up the correct corresponding sides for something we're going to do a little later. So for me, as a person who thinks visually, I have to actually redraw this so that I can see it. So I look at these two triangles and I think to myself, well, how can I get them to line up so that the corresponding angles look like they line up? And so the way I'm going to do this is I'm going to, in my mind, flip this one around so that all the angles line up. So I'm going to draw it like this. Now for some of you, this may make the problem harder, not easier. And if it does that, then you don't need to do this visual flipping. It just makes it easier for me, but it might not for you. So then that would mean, so when I flipped it over so that the 115 here went in the same spot as the 115 here. So that's still R, and then this is 115. And then when I did that, then this P came over here, and so this is 40 over here. And then the Q is 25, and so that goes over here. So all I'm doing is trying to line these up so I can more easily visualize that they're similar triangles. So now my 115 lines up visually with my 115 down here, and my 40 lines up visually with that. You don't have to do that. Like I said, you could just say, well, I know W is 115, so it must correspond with R, which is 115. So now we're ready to talk about which angles are corresponding, which sides are corresponding. So this is the reason why I like to make my new drawing over here, because it makes it easier for me to do this, but you can do it without that flipped drawing there. But so the angles in particular I can do without the flipped drawing. I'm just lining up 115 goes with 115, so that means R corresponds with W, angle R with angle W. So then likewise angle P lines up with angle X. So angle P corresponds with angle X. Okay. And then the last one, angle Q, corresponds with angle Y on the other one. So the angles are fairly easy for me. For me it gets more challenging when I try to do the sides when these triangles aren't lined up, and that's why I like to visually line them up. Because once I've lined it up, like I did over here, then I can just have the sides correspond, but I can also do it using my angle correspondences. So if I know that R corresponds with W and P corresponds with X, then I know that the line RP coordinates with the line WX. It's a little harder to see if you don't draw the flipped triangle. So my sides are, I've got side XW, or XY, sorry, corresponds with PQ. So XY corresponds with PQ, WX corresponds with RP, and then I look back up at my thing, I've got RP and PQ, and so I need QR corresponds with YW. YW corresponds with QR. So we'll get a chance to practice these in class, but just so you see what the concept of corresponding sides means. So I think corresponding angles is a little more intuitive. So we're going to use these to solve some problems. The relationship between the angles in each triangle is given in the triangle. Use the fact that the sum of the angles must be 180 degrees to determine the measures of all three angles of the triangle. So here we have a triangle, and we know that no matter what triangle we're working with, all the angles total up to 180. We've got the measures of each angle. This one is, so this one's X. This one's 22 greater than X, or X plus 22, and then this one is 2X minus 14 here. So still, we know that whatever they are, they all add up to 180. So we know that X plus 22 plus 2X minus 14 all together equals 180. So remember, this was angle L, this was angle M, and this one here is angle N, and all added together, they total up to 180. So then we just use all the equation solving skills that we've been working on. So we have X plus X plus 2X, so that's 4X, and then we have a positive 22 minus 14, so that's going to give us plus 8. So all we're doing is the combining like terms thing that we've done in class, and then that's still all equal to 180. And I'm just going to solve. So X is going to be, so 160 divided by 4 would be 4, so that must be 43. So now you have to think carefully about what does that mean that I just figured out that X is 43, but don't stop there, because your problem asked you the measures of all three angles of the triangle. So that 43 means that x is equal to 43. That's that angle there. So that means m is x plus 22. So since x is 43, that's 43 plus 22, which is 65 degrees. So m is 65 degrees. And then n, this one is going to be 2x minus 14. Our x was 43, so that's 2 times 43 minus 14. So that's 86 minus 14. So we got 72 degrees for n. So now if we're going to check ourselves, we better make sure those all add up to 180 degrees. So 72 plus 65 gives us 137. And 137 plus the 43 over here gives us 180. So we at least solved that correctly. I mean, that assumes we wrote the equation down correctly, but at least they all add up to 180, and we know that part is correct. So here's one similar problem, but without the drawing. So what I would suggest to you is that if you ever have anything that's a geometry problem like this, and you don't have a drawing, I would make a drawing. So it talks about a triangle, XYZ, and so I'm going to draw myself a triangle because I just can't think about things like this without a triangle. And it doesn't matter if I draw it correctly. This is just a sketch for me to put my numbers in. So I'm actually going to draw that a little bit larger. So when I do one like this, it says triangle XYZ. So I'm going to, first I'm going to label my vertices. Doesn't matter where I put them. I can put them anywhere I want. But once I label them, it makes a lot of difference where I put the numbers. So I've called that XYZ. It says Y is 13 degrees more than angle Z, and X is 20 degrees more than angle Z. So that means Z is, the other angles refer to angle Z. So I'm going to call this, what do I want to call it? I'm going to call it A for angle instead of Z, because Z's are hard to distinguish from 2's. So I'm going to call that the measure of angle Z, A. And then I'm going to say, so angle X is 20 degrees more, so that's A plus 20. And then, oops, that's the wrong, yeah, no, that's right. And then angle Y is 13 degrees more. So it's 13 degrees more than Z. And then from there, it's just like the last problem. So we have to make sure those angles all total up to 180. We write an equation based on that, and we solve.